Welcome to Module 10.6, Graphing Linear Inequalities in Two Variables. So this is a lot like at the end of Module 9 where we talk about solving for linear inequalities. Now we're going to graph linear inequalities in two variables. So a couple of definitions regarding to graphing the linear inequality. Something called a half plane. So a straight line separate a plane into two halves. So the point on one side of the line are in one of the half plane, and you're gonna have points on the other side of the line that's in the other half of the plane. So that's called a half a plane. So when we draw a line, we basically divide up our entire plane. Plane is left and right, up and down into two halves. Okay, to the right. Excuse me, I shouldn't say to the right, to the left. It's just basically I got a bunch of points on one half and a bunch of points on the other half. All right. Boundary line. The line itself is called a boundary line. So if the boundary line is included in the solution set when we're graphing the line, then the half plane is said to be closed. All right. Open half plane. If a boundary line is not going to be included in the solution set, then we say the half plane is open. So what that means is, you probably remember this. Sometimes when we draw a line using inequality, we use dashed lines or solid lines. Okay, so when we use solid lines, that means it's closed. Dashed line means it's open. So here is a procedure. So let's kind of go over this real quick. When it comes to graphing linear inequalities, first graph the boundary line, dashed if the inequality is less than or greater than, okay, no equal to. Solid means my plane is going to be closed. All right, solid line if it is equal to, greater than, less than, or equal to. Next, determine which side of the line to shade, okay, using one of the following methods. Okay, so the line itself that we are drawing is the boundary line, okay? So we have a lot of points, okay? We're gonna have a lot of points in either half. So based on the inequality, our answers, our points, okay, that is actually part of our solution set is only gonna be in one of the two half planes. All right. So basically, to indicating all the points on that half, we actually shade, okay? Shade that half plane, basically, okay? So we got two different methods. I actually use method number 2, which is solving the inequality for y, basically write them in slope-intercept form so we can quickly draw the boundary line, all right? If the solution shows y is less than or y is less than equal to, then shade the half plane below the line. So less than, all right, I'm going to write it this way, okay? Less than or less than equal to. So y is less than, or if we read it as y is less than this way, we will shade below the boundary line. All right, if it says y is greater than, remember now, reading from the variable. Now, if I need to write all my equation of the line as a slope-intercept form, that means I'm solving for y. So read from the y, from the variable y. So if you read from the variable y and it says y is greater than, then we will shade above the boundary line. All right. If the boundary line is a vertical, then solve for x. If the solution shows greater than, x is greater than, then we shade to the right. If the solution shows x is less than, then we will shade left, the half plane to the left. Okay. All right, so let me show you how it's done, okay? On the homework or in the Hawks Learning, we do this slightly different. So basically what's going to happen is we got to solve for y, all right? Well, we don't have to solve for y. Well, in a way we do because solving for y, write them as slope-intercept form is the quickest way for us to graph. Now, once you solve for y, you can use your graphing calculator to do this, to find points, or we can just use the y-intercept and the slope to find points. So once I solve for y, I got to determine whether I'm going to use a solid and dash. Then I'm going to enter 2 points. Once I enter the 2 points, then the computer will automatically draw the line for me. Then I'm going to select the region which I'm wishing to shade, which is part of my solution set. All right, so let's take a look. Let me show you how to do this real quick, real simple. Before I begin, let me do one thing real quick. We normally read lines from left to right. So if I have a line going up the hill, okay, up the hill, above it is going to be above the line. Below it is on this side. Don't say left and right, say above and below. If I have a line going down the hill, then above the line got to be on this side. Below the line is going to be on this side. Okay, so above is going to be greater than, below we shade, below will be less than. So solve for y first. You see my variable term is positive. By the way, the coefficient in the constant term is divisible by 3. So I can actually divide every term by 3 and say this is x plus y is less than 9. To get y by itself, all I'm going to do is move my x over. So that's y is less than negative x plus 9. So remember now, when I move a term across the inequality does not change. Only time the inequality will flip is if I divide it by a negative coefficient. So right away, I'm going to write it here, okay? My slope m is -1, which is -1 over 1. My y-intercept, my first point y-intercept, is going to be 0, 9. All right, so one of my points is going to be 0, 9. By reading the inequality, there's no equal to, so I'm going to choose dash lines. All right. Reading from y, this is also saying less than. Less than we will shade below in a minute. Okay, so because everything's going to be below this line is actually part of my solution set. Okay. They'll be included as part of my solution set. All right, so let's use this trick, okay? I showed you this one time before. Use the slope to go to the next point, but do it from the point perspective, do it from algebra perspective or arithmetic perspective. So down 1, that means y value minus 1. To the right 1, x value plus 1. So the other point is going to be 1, 8. And the reason why I'm doing it from this perspective is so I can quickly just enter 1, 8. All right, 0, 9 is up here. 1, 8 to the right 1, up 8. All right, and I select dash line, so the computer now will automatically draw a dash line. Let me do a couple more points, okay? Down 1 to the right 1. Let me do a couple more points just for me. Down 1 to the right 1, down 1 to the right 1. All right, so the computer will draw a dash line. All right, so everything below this dash line is part of my solution set. So this is the part I will shade. So this half a plane, okay, is going to be included in my solution set. So what that means is every single point on this side of the plane will actually satisfy my inequality. So if I pick a 0, 0, if I pick the origin, which is within my shaded area, plug in 0 for x, 0 for y. 0 plus 0 is less than 9. So that inequality will be true. So all these coordinates, all these points on this side of my boundary line, okay, actually satisfy my inequality. Okay, that's what it means to graph linear inequality. Let's try another one, okay? Let me solve it right here, right below it real quick. So this time to get y by itself, my y is positive already, so I'm just going to move my negative 2x over. So that will be 3y greater than 2x minus 6. Divide every term by a positive 3, so inequality does not change. So that's 2/3 x minus 2. So right away, I can see my slope is 2/3. My y-intercept, 0, -2. So that's my first point, is my y-intercept. 0, -2 is right here. All right, so I'm going to use my y-intercept, 0, -2, to go to the next point. So my slope says up to the right 3. So I'm going to say plus 2 on the y value, plus 3 on the x value. So my next point on the line got to be 3, 4. So that will be the other point I enter. 3, 4. Up to, hold on a minute, that's -2. I'm sorry, not 4. This is 3, 0. Sorry about that. 3, 0. Hold on a minute. Up to, Jesus, what am I writing? All right, hold on a minute. Up to the right 3. So that will be 3, 0. Okay, 3, 0. So up to the right 3, that will be about right here. All right, by looking at the inequality, all right, there's no equal to, so I'm going to choose dash line. All right, read from the variable y is greater than, so my dash line, right? Here's my dash line. Y is greater than means we'll shade above it. So above this boundary line, this side of the plane is where all my solution gonna be, okay? It's open because the points on the line is actually not part of my solution. So closed with the equal to, that means the points above it or below and the points on the line is part of my solution. So the dashed line means only points on that side that I'm shading that will satisfy my inequality. But the points but the points on the line are not. Okay, that's the difference between closed versus open. All right, so this one has an equal to, so I would choose a solid line here in a minute. So let's get y by itself. Since my y is already positive on the right-hand side, I'm just going to bring my -18 over. So my inequality should say 6y less than equal to 3x is 3x, -18 come over, become positive. Divide every term by a positive 6. Then my y is going to be less than equal to 1/2 x plus 3. All right, so my slope m is going to be half. My y-intercept is going to be 0, 3. So that's my first point, 0, 3. With the equal to, I use solid lines. All right, so let's use my slope. Up 1 means y value plus 1, to the right 2, x value plus 2. So that's 2, 4. All right, 0, 3 is right here. To the right 2, up 4 is right here. So this is the next point. I'm using a solid line. All right, read from the inequality. Y is less than, so this time I will shade below. So basically this is a closed, all right, closed half plane. That means the boundary line is included in the solution set. So that means the points on this line and below will satisfy my inequality. All right, so this is the region you will select. All right, let's do this, okay? Ooh, interesting problem. Do you see a -4y and a -4y on the right and left of the inequality? What happened to them? They automatically what? Cancels out. So that means this equation of the line only contains variable x. So if you only have variable x, that's automatically a vertical line. So to get x by itself, just like we done before, divide both sides by 4. My x is now greater than or equal to 2. All right, so greater than or equal to 2 means we will shade to the right side of this vertical line. All right, so solid line, because there's an equal to. I need points. I know my x got to be 2, but my y value can be anything I want them to be. So I'm just going to say 1 and 4. So 2, 1, 2, 4. To the right 2, up 1. To the right 2, up 4. So here is my vertical line. That will be solid. All right. And the inequality says x is greater than or equal to 2. So all the x value greater than or equal to 2 will be on the right side of the vertical line. All right. That's all it is. All right. It's a closed boundary line. All right. This one, same thing. No variable y. So this is another vertical line. If I just move the -3 over, that's going to be x less than 3. So by reading the inequality, I know I'm going to use a dash line. Less than means I will shade to the left of my vertical line. So let's get some points, just like the previous one. X value got to be 3. Y value can be whatever you want. To the right 3, up 1. To the right 3, up 4. So this time that will be a dash line. All right. I'm looking for all the points, okay, to the left side of my vertical line. So I will shade everything to the left. This half of the plane is where my solution at. Because every single x value on this side is less than 3. Okay, that's what that means. All right, so if you run into a problem where a problem where the equation only have a y in it, then that means we will draw a horizontal line and shade according to the inequality. All right, so in this lecture video, we talk about how to graph linear inequality, where we have to end up shading, okay, the half plane, okay, that will actually satisfy the inequality, where the points in those half plane will satisfy my inequality. All right. Now we'll conclude this lecture video and conclude module 10 videos. Thank you for watching.